Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hello dear students, welcome back. Welcome to the beautiful channel of Brilliant Katha. Today we discuss the important chapter Mechanical Properties of Fluids in our live DPP session. Okay, the first question is, a water drop of diameter 2 centimeter, a water drop of diameter 2 centimeter is broken into 64 equal droplets. The surface tension of water is 0.075 Newton per meter. In this process, the gain in surface energy will be, here a bigger drop is splitted into 64 identical drops. 64 identical drops. Okay. In the process, the final energy, surface energy, is greater than the initial surface energy because the final area is increasing. Okay. Now, we know what is surface energy is equal to surface tension into area. Surface energy is equal to surface tension into area. Okay. Now, the gain in surface energy, is equal to surface tension into the increase in area. Surface tension into increase in area. This is equal to S into final area. Final area is N into 4 pi r square. N means here 64 in the question. Okay. Minus initial area is 4 pi r square. Clear? We have the connection between the radius of each smaller drop and the radius of this bigger drop, capital R, connected by the equation. We are just equating their initial volume of this one and final volume. We get 4 by 3 pi r cube is equal to n times of 4 by 3 pi small r cube. Okay. Which get r is equal to n raised to 1 by 3 into small r. This is the connection between those radii. Okay. Now this small r is equal to capital R divided by n raised to 1 by 3. Okay. Now this small r square is, here we put this gain in surface energy. The gain in surface energy is equal to, here it is equal to this one. This one, if we proceed, S into n into 4 pi is taken outside. 4 pi is taken outside. Okay. 4 pi is also taken outside. S into 4 pi into n into, what is this small r square? Small r square is r square by n raised to 2 by 3. Okay. Minus 4 pi. 4 pi already taken, here r square. Okay. R square also can be taken outside. So this is S into 4 pi r square, the bigger surface area or surface area of the bigger drop, 4 pi r square, into, in the bracket, this is n divided by n raised to 2 by 3. That is equal to n raised to 1 by 3. Okay, n raised to 1 by 3 minus 1. Yes, n divided by n raised to 2 by 3. This is your formula of gain in surface energy. Gain in surface energy is equal to, keep this formula in mind, gain in surface energy is equal to surface tension into 4 pi r square, that is a bigger area, into n raised to 1 by 3 minus 1. Clear? Now in the question, surface tension value given 0.075 into 4 pi into radius square. See, this diameter is 2, so radius is 1 centimeter. Its square is 10 raised to minus 4. Okay, now n raised to 1 by 3, that is 64 raised to 1 by 3, cube root of 64, that is equal to 4. Okay, 4 minus 1, 4 minus 1, 4 minus 1, that is 3. Clear? 0.075 into 4 pi into 10 raised to minus 4 into 3. Okay, we solve it, we get the answer, which is option A, 2.8 into 10 raised to minus 4 joule. Okay, yes, that is the answer, which is option A. So keep this in mind. In this context, a bigger one splitted into tiny ones means energy is gained. Now this is the formula. In the opposite case, coalescing, then energy is lost. Energy is lost, and we can use the same formula. Okay, energy is lost. Okay, energy lost or energy gained, we will have the same magnitude. Same magnitude will be there. Okay, yes. Now moving to the second. A water drop of radius 1 centimeter is broken into 729 equal droplets. If surface tension of water is 75 dyne per centimeter, then the gain in surface energy. Students, this is a similar question. The exact question it is, just values are changed. Okay, what is the gain in surface energy? Gain in surface energy is equal to surface tension into surface area of bigger drop into n raised to 1 by 3 minus 1. By heart this formula. Okay, here the values are, surface tension value is 75 dyne per centimeter. Convert that dyne per centimeter into Newton per meter. Dyne is 10 raised to 5 Newton and centimeter is 10 raised to minus 2 meter. Okay, into 4 pi into square of the radius is 1 centimeter square is 10 raised to minus 4. Okay, n here 729. 729 raised to 1 by 3. 729 raised to 1 by 3, cube root of 729, it is 9. It is 9 minus 1. Cube root of 729 is 9. 9 minus 1, this is 8. Okay, solving this, we get, this one is 10 power minus 5, 10 power minus 9, 10 power minus 2, so 10 power minus 7 here. 75 into 4 pi into 8. We solve it, we get the answer, this one 7.5 into 10 raised to minus 4. You can easily solve it. We are not spending much time on it. Okay, we can move into the next question. This is only a similar question of the previous one. Students, keep this in mind of gain in surface energy in the case of splitting of a bigger drop into many identical drops. Okay, now the third one is, consider a cylindrical tank, there is the picture, of radius 1 meter. The cylindrical tank of this radius, this cylindrical tank whose radius is 1 meter is given. Okay, filled with water. The top surface of water is at 15 meter from the bottom. 15 meter is the total height. There is a hole on the wall of cylinder at a height of 5 meter from the bottom. At a height 5 meter means at a depth of 10 meter from the surface. Okay. A force of 5 into 10 raised to 5 Newton is applied on the top surface of water using a piston. We can see that. The speed of efflux, the speed of efflux from the hole will be, what is the velocity of efflux? In this case, consider liquid is taken in a container. Up to this is the liquid. Here the pressure, let it be P, and here is the hole. Here the pressure is the atmospheric pressure PA. Okay, let this hole is at a depth of h from the water surface or liquid surface, right? Then the liquid will be ejecting through the hole with a particular velocity named velocity of efflux. Clear? Now, the equation of velocity of efflux is derived by applying Bernoulli's principle, well known Bernoulli's theorem, that square root of 2gh plus twice of the pressure there in the top minus atmospheric pressure divided by rho. This is the formula. Now we put the values there, very direct. Okay, what is this? Root of 2 into g is 10 and h is, what is this? H is the depth, not this one, 5 meter. It is not the case. This depth is the h value there, that is 10 only. 10 plus 2 into, what is the pressure here? See, the pressure here is equal to force divided by area. Force divided by area is the pressure applied here. Force is 5 into 10 raised to 5, isn't it? Divided by, what is the area? Area of this one is pi r square. Okay, this is a circular area. Pi r square, pi into square of the radius. What is the radius? Is 1 meter. So pi into 1, that is simply pi. Okay, 5 into 10 raised to 5 divided by pi minus atmospheric pressure 1 atm. It is simply 10 raised to 5 Pascal approximately, just greater than 10 raised to 5. Okay, divided by density of water is 10 raised to 3. Clear? Now 10 raised to 5 taken out z, 10 raised to 5 by 10 raised to 3 is 10 raised to 2. This is 200. This is also 200. So root of first term is 200 plus second term is also 200 into, in the bracket it is 5 by pi minus 1. Isn't it? One thing we can do, see, multiply and divide with a pi here. We can do this one like 5 by pi is very simple. But I am doing like this. So this is, this pi square we take as 10. Then this 5 by 10 is 1 by 2. This is pi by 2. This is pi by 2 means 1.57. So we apply here 1.57. Minus 1 is 0.57. 200 into 0.57 is just greater than 100. Greater than 100. Plus 200 is, so this is just greater than 300. So root of 300 value. Root of 300 value is not 11.6. That is not the case. This is not the case. 10 point is not the case. 17 point is the possible value. 14.4 is not root of 300 plus value. So the answer is 17.8 meter per second. It's very easily understood. By applying Bernoulli's theorem, we obtain the equation of efflux, velocity of efflux. Very good. The next question, fourth. Water from a pipe is coming at a rate of 100 liters per minute. Okay, from a pipe. If the radius of the pipe is 5 centimeter, radius of the pipe is 5 centimeter. The Reynolds number for the flow of the order of. Okay, Reynolds number. What is the idea of Reynolds number? It is a dimensionless, unitless number. Okay, based on its value, we define whether the flow is turbulent or streamline. Okay, if the Reynolds number is less than 1000, the flow is streamline. If it is greater than 2000, it is turbulent. If it is between 1000 and 2000, the flow is unpredictable. That's the idea. Yes. Now Reynolds number is rho Vd by eta. Rho Vd by eta. Rho is the density, V is the speed of flow, D is the diameter of the pipe. Diameter of the pipe, eta is the coefficient of viscosity. Clear? Now, dear students, here rate of flow is given. This is the rate of flow 100 liter per minute. That is volume per minute. Volume per minute. That is actually area into velocity. Area into velocity is given. Area into velocity is volume per time. Volume per time, we studied that. This is given 100. Liter is converted by 10 power minus 3 to meter cube. And per minute is converted by 60 there. Now this is in SI system. Okay. Now from this value we get this V. V value we get to put here. Diameter is given. It is radius 5 given. Coefficient of viscosity is given 1 millipascal second. Okay, coefficient of viscosity is 1 millipascal second. Pascal second is the SI unit of coefficient of viscosity. Okay, putting the value, density is 10 raised to 3. Speed is this by A. This by A. This is 10 power minus 1. 10 power minus 1 divided by 60. Divided by area. Area is, what the area is pi r square, pi into, what is the radius is 5 centimeter. Its square is 25 into 10 raised to minus 4. Okay. Now into this diameter is 10 centimeter. 10 centimeter. Okay. Divided by coefficient of viscosity is 1 millipascal second. Okay. This to be calculated. Clear? So, in the numerator, 10 power 3 into 10 power minus 1 is 10 power 2, then 10 power 3, then 10 power 1. This is 10 there. Then here that 10 and this 0 is cancelled. Then this one 10 power minus 4, 10 power minus 3, 10 power minus 7 taken to numerator, it is 10 power 7. Here it is 6 pi into 25. Okay, 6 into 25, 150. 150 into pi is just less than 500. So this one I can take this 1000 into 10 raised to 4 divided by a number under 500. A number under 500. This is 2 into 10 raised to 4. So the question is about in order of, see, all these are 10 power 2. This is 10 power 2. This is 10 power 4. This is 10 power 3. This is 10 power 6 only. Okay. Now the answer is in the order of 10 power 4 is the answer. See, very simple. Okay. The idea of Reynolds number rho Vd by eta, remember this is a dimensionless, unitless constant. Yes. The next one, that the ratio of surface tensions of mercury and water is given to be 7.5. The ratio of surface tension of mercury divided by surface tension of water is given by 7.5. Yes. While the ratio of their densities is 13.6. Density of mercury divided by density of water is 13.6. Okay, this is also called relative density, or it is also called specific gravity. Okay, there is another term. Okay, now what is this? Their contact angles with the glass are close to 135 degree and 0 degree. 135 degrees. See, the angle of contact for mercury with the glass is given 135 degree, and for water it is given 0 degree almost. Yes. It is observed that mercury gets depressed. Okay, capillary depression is observed in the case of mercury, and capillary height is observed in the case of water. Yes, the amount of depression is h here in a capillary tube of radius r1, while in the case of water it rises by the same amount. Okay, depression and height both are in equal amount. But this is in another tube of radius r2. Now the question is, what is the radius ratio r1 to r2? See, the equation of capillary rise or depression is h is equal to 2s cos theta divided by r rho g. Okay. Yes, this is the equation of capillary height or depression. Okay, the height or depression depends on this angle of contact. If it is obtuse, there is depression. If it is acute, there is height. Okay, now in this question, given that this height and depression are same, h1 is equal to h2, but one is height and the other one is depression, so I am taking a negative sign there. Okay, then it means s1 cos theta 1 divided by r1 rho 1 is equal to s2 cos theta 2 divided by r2 rho 2. Clear? And the question is about r1 divided by r2. What it is? r1 by r2 is equal to s1 by s2, then cos theta 1 by cos theta 2 into then rho 2 divided by rho 1. Rho 2 divided by rho 1. Okay, and here is what is s1 by s2, and here is negative signs there. No, one is depression and the other is height. Negative sign and negative sign is there. Okay, now s1 by s2 is given 7.5 in the question. 7.5. Then cos theta 1 is cos 135 divided by cos theta 2 is cos 0. Cos 0. Then rho 2 by rho 1 is given 1 by 13.6. Okay, 1 divided by 13.6. Now remember, this cos 135 is minus cos 45. Okay, cos 180 minus theta is minus cos theta. So this is minus cos 45, minus minus is cancelled. Okay, this is equal to 7.5 into cos 45 is 1 by root 2, then divided by 1 by or into 1 by 13.6. Clear? This is our answer. This is our answer. Okay. Now see, this is 1.41. When we calculate this, we get that this is equal to the ratio. This ratio is equal to 4 by 5, 2 by 3, 3 by 5. This will be our ratio. 3 by 5 is our ratio. We can easily check that. This value, and you check this value 3 by 5, that is root 0.6, and you can check this value also. see, this is not 3 by 5, this will be the answer. 0.4 in that range. When you calculate this, we get it is almost 0.39. You can easily calculate. We don't waste much time for that. And the answer is 2 by 5. Just a comparison. Okay? Yes, very fine. This is the idea of capillary height or depression. That's it. The next one, sixth. Water from a tap emerges vertically downwards with an initial speed of 1 meter per second. There is a pipe. From the pipe, water is vertically coming out with a speed of 1 meter per second. While it descends, it is getting narrowed due to the increase of speed. As V increases, area decreases. That is the equation of continuity. We studied that A1 V1 is equal to A2 V2. This is the well-known equation of continuity. As the speed is increasing, area is decreasing. Here the speed is given V1 as 1 meter per second. And this area is given in the question as 10 raised to minus 4, 10 raised to minus 4 meter square. Okay. Now this area is asked actually in the question. What is the second area is asked? For that, we require this velocity V2, how much it is. Now from this expression, what is A2 is equal to very direct equation only. A2 is equal to A1 V1 divided by V2. A1 is 10 raised to minus 4, V1 is 1. Then V2 is equal to, what is this V2? By the basic expression of kinematics, from the equation of kinematics, this V2 square is equal to V1 square plus 2GH. Okay, then what is V2 is root of V1 square plus 2GH. Yes, this is equal to 10 raised to minus 4 divided by root of V1 square is 1 plus 2 into 10 into, what is this height given in the question is 0.15 meter. After a depth of 0.15 meter, what is the area is asked? That is 0.15 here, isn't it? 10 power minus 4 divided by, what this is 10 into 0.15, 1.5 into 2, that is 3, 3 plus 1 is 4, root to 4 is 2, root to 4 is 2 means this much. Okay, 1 by 2 is 0.5. 0.5 into 10 raised to minus 4, that is 5 into 10 raised to minus 5, very easily calculated. Meter square is the SI unit of area. 5 into 10 raised to minus 5 meter square. Understood? Very simple. Very simple. The idea of equation of continuity and an equation from kinematics. Okay, very good. Now, seventh one, a submarine experiences a pressure of 5.05 into 10 raised to 6 Pascal. You take this Pascal at a depth of D1 in a sea. When it goes further into a depth of D2, it experiences a pressure of 8.08 into 10 raised to 6 Pascal. Okay, what are the pressures? At a depth D1 from the water surface, the pressure is 5.05 into 10 raised to 6 Pascal, and at a depth D2 further, the depth is increased and it is 8.08 into 10 raised to 6 Pascal. Clear? Yeah. Now, then D2 minus D1 is approximately, density of water is given, acceleration due to gravity is also given. Listen, this one is, what is 1 atm? We know 1 atm is approximately 10 raised to 5 Pascal. So this one is, I can write 50.5 atm approximately. 50.5 into 10 raised to 5. And this one is equal to 80.8 atm. Okay, now these two pressures, there is approximately a difference of 30 atm. Okay, these two pressures approximately a difference of 30 atm. Okay, now we understand that the water pressure, the gauge pressure, what is the gauge pressure is H rho G, corresponding to 10 meter of water, corresponding to 10 meter of water, corresponding to 10 meter of water, this becomes 10 raised to 5 Pascal. You just check it. 10 into 10 raised to 3 into 10. 10 into 10 raised to 3 into 10 means 10 raised to 5 Pascal. What I mean that corresponding to 10 meter of water, there will be a pressure of 1 atm. Then what is the height corresponding to 30 atm? 30 atm means 30 into 10. 30 into 10 means 300 meter. That's it. It's very simply done. Otherwise, we proceed as the normal case. But this is very simply done. This pressure difference is 30 atm. Every 1 atm pressure difference equivalent to 10 meter depth of water. 10 meter depth of water. Then 30 into 10 meter is 300 meter difference is there. Understood? 300 meter difference is there. So the answer is option C. Very good. Okay, it's very simply done. Moving to the next one, 8. A solid sphere of radius r acquires a terminal velocity v1. This is a question of terminal velocity, an important concept. When falling due to gravity through a viscous fluid having a coefficient of viscosity eta. Yes, the sphere is broken into 27 identical solid spheres. Again this broken into, see, this is a solid sphere now broken into tiny drops of total number is 27. Clear? Now there will be change of radius. Okay, accordingly there will be change of terminal velocity, because we understand that the expression of terminal velocity depends on, or terminal velocity directly proportional to r square, square of radius. Okay, then what this ratio v1 by v2 is asked? v1 by v2 is r1 by r2. r1 by r2 all square. Let this radius be r1 and let this tiny radius be r2. Clear? Then we have an expression, this r1 is equal to n raised to 1 by 3 times of r1. This r1's greater radius is n raised to 1 by 3 times of r2. We studied it. Then what is this r1 by r2? r1 by r2 is n raised to 1 by 3. n raised to 1 by 3. r1 by r2 is n raised to 1 by 3. All raised to 2 is n raised to 2 by 3. n raised to 2 by 3. And what is n here is 27. 27. So 27 raised to 2 by 3. Isn't it? 27 cube root of 27 the square. What is cube root of 27? 3. 3 square is 9. So very simply done, the answer is 9 times. v1 by v2 is equal to 9 is the answer. Understood? Okay. Now the question is 9th one. Pressure inside two soap bubbles. This is a bubble. Okay. Soap bubble. Yes. Soap bubble having two areas, outer area and inner area will be the two surface areas for a soap bubble. Keep it in mind. Pressure inside two soap bubbles are 1.01 and 1.02 atm respectively. The ratio of their volume is, first of all, what's the idea of excess pressure? See, inside a drop or bubble, pressure inside will be greater than pressure outside. That's the idea. Means the excess pressure delta P is Pi minus Po. This is the idea of excess pressure. And the equation of excess pressure in the case of a bubble is 4S by R, where S is the surface tension. We understand this excess pressure is directly proportional to 1 by R. Clear? Now we understand this excess pressure ratio delta P1 by delta P2 is R2 divided by R1. Let it be here. Okay. Now in the case of first bubble, what is inside pressure and what is outside pressure? In the case of first bubble, delta P1 is inside pressure is 1.01 atm and outside pressure is 1 atm. Outside pressure is 1 atm, which is equal to 0.01 atm. And in the case of second bubble is inside pressure is 1.02 and outside pressure is 1, it is 0.02. Isn't it? Okay. Now what is this ratio? Delta P1 by delta P2 is the ratio of their radii, inverse ratio of their radii, inverse ratio. And this value is 0.01 by 0.02, that is 1 by 2. This 1 by 2 is actually R2 divided by R1. We understood it. And here in the question they are asking the ratio of their volume. What the ratio of their volume V1 by V2 is equal to R1 by R2 all cube, because the volume is directly proportional to R cube. Then what is R1 by R2? R1 by R2 is 2. See, R2 by R1 is 1 by 2, so R1 by R2 is 2. 2 cube is 8. So the answer is 8. Simply done. Answer is 8:1. That's the answer of the question. So the idea of excess pressure first, and the equation of excess pressure in the case of a bubble, 4S by R. And remember, in the case of a drop, it is 2S by R. Keep it in mind. 2S by R in the case of a drop, and the case of bubble, it is 4S by R. Okay. Here no problem of 4 and 2. It is just cutting, and this is the ratio only. And we are getting the answer 8:1. Okay, the final question of today's DPP discussion, that a hollow spherical shell at outer radius Kevlar floats just submerged under the water. Floats just submerged under the water surface. The inner radius of the shell is smaller. If the specific gravity of the shell is this one, specific gravity means what? Relative density. Density of the shell divided by density of water. Okay. Then the value of small r is, see, the condition is this is surface of water and here is a shell is just floating. Okay, it is having this much material is there. Okay, this is small r, this is small r, this is small r, and this one is capital R. Okay, now we understand that the net force is balanced, that's why it is keeping there, it is floating there, means its weight mg downward is balanced by the buoyancy Fp, isn't it? Now the buoyancy is defined by Archimedes, that buoyancy is equal to weight of the displaced liquid, weight of the displaced liquid, isn't it? Weight of the displaced liquid is mass of the displaced liquid into g, mass of the displaced liquid into g. Okay, now this is in equilibrium, means net force is balanced, means mg is equal to m dash g. Okay, mg is equal to m dash g, gg cut. Mass of this body is balanced by the mass of the displaced liquid, m dash. Okay, now what is mass is volume into density. Now this one, this mass is this volume into density, volume of this shell, I can write volume of this shell into density of the shell is equal to what, this displaced mass is the volume of the displaced water, volume of the displaced water into density of water, isn't it? Yes. Now this is equal to, what is this one? This gives that, what this volume of the shell is 4 by 3 pi into capital R cube minus small r cube. Okay, now this density of the shell is equal to what, this volume. See, actually this shell, it is a spherical one. It's a spherical one, is completely immersed. So how much volume of water will be displaced? 4 by 3 pi r cube. Understood? 4 by 3 pi r cube will be displaced. 4 by 3 pi r cube will be displaced, then density of water. 4 by 3 is cancelled, isn't it? Then this r cube taken to this side, we get r cube by r cube is 1 minus r cube by r cube is r by r all cube, isn't it? This is equal to density of water divided by density of shell. Okay, yes. Now what is this one given? This one given that 8 by 27. Okay, this one, density of shell by density of water is 27 by 8. This is 8 by 27. This is 1 minus r by r all cube. The question is smaller. Okay, so what this r by r all cube is equal to 1 minus 8 by 27, isn't it? 1 minus 8 by 27 is what? This is 27 minus 8, that is 19 divided by 27. What? This r by r all cube. Okay, yes. Now what is this? R by r is equal to 19 divided by 27 raised to 1 by 3 into capital R, into capital R. Okay, sorry, this r by r is equal to, this r is equal to, this r is equal to, this r is equal to 19 by 27 raised to 1 by 3 into capital R. Now you just observe these values. See, this 2 by 3, this 2 by 3, just take the cube of this one, will you get 19 by 27? No. Cube of this one is 8 by 27. So this is not the answer. Okay, that is not the answer. Now you just take the cube of this one. 4 cube is 64, then 9 cube is 729. So this is not the answer. Now you just cube of this one, 1 by 27 is not the answer. Definitely this will be the answer. We can easily check that. Understood? Students, we discussed today some of the important concepts of mechanical properties of fluids. Actually the chapter is a bigger one. Okay, you please go through with the other concepts also. Okay, you can easily understand. The chapter is actually simple and you can easily score in JEE Main examinations. Okay, good luck, all the very best. Thank you.
Hi everyone, welcome back to the live DPP session of Master JEE Chemistry. I hope all are doing well, I hope so. Hi, comment box, please burn it. So today we are going to discuss about the very important, yes, Ashmita Chakravarti, yes, yesterday I didn't see you, okay. So anyhow, today we are going to discuss about the very important topic, that is hydrocarbon. Okay, so very important. Yesterday we discussed about GOC, general organic chemistry. Today we discussed in the class hydrocarbons. So we are going to do the very important question from the chapter hydrocarbons. Okay, ready? Yes, Prajesh. Hi Prajesh. Okay, great to see you. So here we are going to do this question. What about the first question? While we are doing this, while we are seeing this question, benzene ring is there, that is treating with some alkyl halide in presence of AlCl3 anhydrous. Once you are seeing this one, that time itself you must have to understand that this one actually represent what? That is actually the Lewis acid. In presence of Lewis acid, electrophile is going to form. What is going to form? Electrophile is going to form. So electrophilic substitution is going to happen. So while we are looking this one, you know the reagent is CH3, CH, and here CH3. Listen to me carefully, CH3, and here CH2, okay, and here Cl. So what this AlCl3 will do? It will split, it will break this bond heterolytically. How heterolytically? This chlorine will take that electron and it will become Cl minus. It will become Cl minus. What is remaining there? What is remaining there, guys? Listen to me, you can see CH3, CH, and CH3, CH2, and plus charge will come here. You may be thinking like that. Yeah, this is the electrophile. This electrophile will go and replace the hydrogen here in benzene ring, and you may be thinking like that. Yeah, that is happen, but not happen like that. Yesterday I told you in the last question, in the last discussion of GOC, I told you this is carbocation. This carbocation will always try to get, this always try to become stable. For that they will undergo some rearrangement. Here what will happen? How? This is actually primary. If this plus comes in the next carbon, I hope you can see, if this plus is here, if that plus is here, then it will be tertiary. So for that what will happen there? For that what will happen there? Listen to me very carefully, this hydrogen will shift to this carbon. That is called a from 1 to hydride shift. So that plus will come to here. So what kind of compound you will get? Listen to me. What kind of structure you will get? Listen to me carefully, guys. Listen to me. Okay, so here what is happening here? This plus I am going to take to here. So that will become, you can see I will draw it here. You can see CH3. Listen to me carefully, guys. Yes, CH3, CH3, and here this H will go to there, and it will, this C only remaining there. Okay, that C only remaining there, that H will go to attach with that CH2, that becomes CH3, and plus come here. Now it is a tertiary carbocation that will go and replace the hydrogen from here. Here hydrogen is there. That hydrogen is the electrophile. It's a weak electrophile that will be replaced by this group. So which answer will come? Which answer will come? So this answer will come. B answer will come, because this is actually this carbocation only coming and attaching with that one. Normal electrophilic substitution reaction. I hope idea is clear. Ready? Yes, Fahad. Yes. Ashmita. Ready? Yes. Option B is the correct one. So you have to remember that hydride shift, or else answer will be wrong. Okay, guys, ready, come on. Yes or no? Yes, Siddharth, yes. So you have to remember that what? You have to remember hydride shift to form tertiary carbocation. Yes, Ashmita, hydride shift. Okay, that's the thing. Okay, so then again we can move to the next question, guys. That's the next question. That's a very important question. The highest boiling point is expected for. So I taught you that idea very clearly. Boiling point directly proportional to number of carbon atom. Okay, number of carbon atom. When number of carbon atom increases, boiling point increases. Boiling point directly proportional to molar mass. Molar mass increases, boiling point increases, and boiling point is directly proportional to intermolecular hydrogen bonding. Intermolecular hydrogen bonding. In your organic compound, if there any possibility of intermolecular hydrogen bonding, their boiling point will be very much higher. Okay, and boiling point is inversely proportional to branching. So if there any branching is there, means boiling point will decrease. Now let's check. Here isooctane is there. Iso means obviously branch, similar to the octane. And normal octane means chain. 8 carbon containing chain. Okay. And this is 2,2,3,3 tetramethyl butane. Here tetramethyl means 4 carbon is there. Tetramethyl, 4 carbon is there. In butane also 4 carbon. So total 8 carbon are there. Ready? What about here? Normal butane. Only 4 carbon is there. So what's the answer? Longest chain. without branching. So answer is 8 carbon containing one. So normal octane. Idea is clear, guys. Ready? Ashmita, Fahad, Siddharth. Yes, Siddharth. Nice to see you in the live. Okay. Great to see you. So this the highest boiling point is expected for. The answer is octane, normal octane. You have to, whenever you are understanding the answer, means you have to put the fire, you have to put the heart. I'm waiting for that. Ruben, yes, Ruben Johnny, yes, great to see that, okay, yes. So then we can move to the next question, guys. This is the 13th question. Yes, you can put the heart, then only I can become more energetic. Okay, the energy we are showing here, it is actually the love, the affection you are showing towards us, okay, through the comment box. Okay, so ready? So cyclopentadienyl anion is, okay, cyclopentadienyl anion is, okay. So here cyclopentadienyl anion, what do you mean by cyclopentyl? Cyclopentyl is this one. This is cyclopentyne. Okay, here cyclopentadienyl means double bond, and anion is, they are asking about anion. Anion means here negative charge. If it is positive means carbocation. Okay, they are asking about this compound, this species, it is aromatic, non-aromatic, non-planar, aliphatic. What to do, guys? Here while we are looking, it's a cyclic one. All carbon atoms are sp2 planar. And alternate double bond, single bond, and lone pair, single bond, double bond, single bond. Its conjugation is there. What is there? Conjugation is there. And how many electrons are there? All electrons are delocalizable. You can show the resonance like this. So here resonance coming means here negative charge will come, here double bond, here double bond. Next resonance, this will come, this will go here. So that means total how many electrons are participating? This two, as well as this negative containing 2. Total 6 pi electrons are there. So it obey 4n plus 2 is equal to 6. N equal to, you will get 6 minus 2, 4. I mean 4 by 4, that means 1. So n value is 1, so that is possible. 6, 10, etc. coming means, I mean multiple of 4 plus 2. Multiple of 4s are 4, 8, 12, etc. That plus 2. Pi electrons are there means they are aromatic. So this is aromatic one. So option A is the correct one. Ready? All of you got it? Yes, Fahad, yes, got it right. Yes, aromatic, option A. That's it. Okay. So then we can move to the next question. This is the 14th question. What's the 14th question? Ozonolysis of buta-1,3-diene gives. Okay. Ozonolysis of buta-1,3-diene gives. So here you are having buta-1,3-diene. Buta-1,3-diene means this is the buta-1,3-diene. CH2, double bond CH, single bond CH, double bond CH2. This is 1,3-butadiene. So we are conducting ozonolysis. I taught you a shortcut to find out the answer for ozonolysis. No need to write the entire steps. What we will do, guys? We will break the double bond. Ozonolysis means you are conducting ozonolysis means that time you have to remember this idea. You have to break the double bond. You have to put one O here, one O here. Break the double bond, one O here, one O here. O, okay, ready? And you have to break the double bond here, one O here, one O here. So what is the answer? CH2O is there. Then CHO, then CH2O. So CH2O is called methanol. This is also methanol. So this is actually 1 and 2 carbon containing aldene, ethane 1,2 diol. That's also called glyoxal. So what's the answer, guys? HCHO and glyoxal is the answer. Option A is the correct one. Ready? Yes, Ruben Johnny, yes, ready, sir, easy questions, sir. Fahad, Anbol is telling yes, easy question, yes, Ashmita, yes, Siddharth, option A is the correct one. So whenever you are seeing double bond, you have to break it, put one O here, put O in the left hand side, put one O in the right hand side, then you have to read it as a ketone or aldehyde, okay, according to your wish. Ready now? So if it's so, then we can move to the next question. This is the next question, 15th question. Easy one. Very easy one. Wood's reaction using bromoethane yields. So you are having bromoethane, CH3, CH2, Br. This is bromoethane. What is happening during the normal Woods reaction? The number of alkyl group will double. So you are conducting, okay, I am writing the reaction, no, nothing, 2Na plus Br, CH2, CH3, okay, you have to treat with the dry ether, don't forget to take dry ether. If you are taking wet ether means alcohol will be the product, so this will be going, and what will be happening, CH3, CH2, CH2, CH3, so you will get butane. Normal butane. It's an easy one, very easy one, simple one, okay, normal butane is the answer. I hope you got it. Ready? Yes, Ruben Johnny. Yes, Karthik. Yes, Ashmita. Yes, 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 yes. Yes, 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 yes. Double the number of carbon atom. Whatever you are taking, then double the number of carbon atom. Then intra Woods reaction is there, and then mixed Woods reaction is there. That and all we learned. Okay. In mixed Woods reaction, we have to take more than one haloalkane. That time more than one product will be forming. Okay. That idea we discussed in the class. Anyhow, we can move to the next idea. Next question. 16th question. What about this question? They gave this idea we discussed in the class. Today also we discussed in the class. You are having CH3. Listen to me. CH3, C, triple bond C, CH3. Once you are treating this one with a Lindlar catalyst. Lindlar catalyst means partially deactivated palladized charcoal. How we are deactivating the palladium? By using and charcoal as well as barium sulfate as well as calcium carbonate as well as quinone, because to control the release of hydrogen, that only Lindlar catalyst. So you will get an alkene, hydrogen addition will take place. This will be become, listen to me carefully, CH3 C double bond C CH3. Here hydrogen will be come and added. Here hydrogen will be come and added. So that is a syn addition. At the same side only hydrogen will added, syn addition. So you will get a cis product. Syn addition means in the same side it will come and added. Ready? Yes. And instead of this one, if we are using sodium in liquid ammonia means sodamide. Sodamide will form, along with that hydrogen will be forming. That is actually called, that idea is called Birch reduction. Birch reduction means what will happen? Just opposite only hydrogen will be added. C double bond C, here CH3, here CH3, here H, here H. It will be a trans product. It will be what? It will be a trans product only you will get. So in the case of Lindlar catalyst, you will get a cis product. In the case of Birch reduction, you will get what? Trans product. That is anti-addition will take place. So what's the answer? A is cis, and both are butadiene. Okay, both are butadiene. A is cis and B is trans. Cis and trans to butene is the answer. Okay, don't forget the idea. Similarly, one more idea I taught in the class: iodine and CH3COOH, acetic acid, wet and dry. Okay, that idea also you remember, I hope so. Yes or no? Ready, guys? Yes. And the comment box is full of with love and affection. Okay, great to see that, guys. Okay, then we can move to the next question. 17th question. This is the 17th question. Calcium carbide. Okay, listen to me carefully. Calcium carbide. We are taking calcium carbide. We are treating with H2O. You know that while you are treating calcium carbide with H2O means this actually calcium 2+. Okay, carbide is C triple bond C plus. Sorry, minus. I'm sorry, chemistry code. Minus. Okay, C triple bond C minus. That one you are treating with H2O. H2O means what? H2O means H plus and OH minus. Likewise, two molecule if you are treating means what will happen? This will join together because this plus and minus will join together. So that will form CH. That means C2H2. CH triple bond CH will form. This is ethine or acetylene will be formed. Okay, now you know the equation, you know the reaction, and the Ca2 plus and OH minus will be coming together, and that will form CaOH2 as the byproduct. It's actually artificially fruits and all are ripening by using this carbide, because the artificially ripening agent is this ethyne. Okay, this ethyne is getting, that ethyne you are treating with what? You are conducting oxymercuration, oxymercuration. H2SO4, HgSO4 means you are adding water. You have to add water to this CH triple bond CH. What you will get, guys? What you will get? You are adding CH triple bond. I will draw here. I hope you can see this one. CH triple bond CH. To that you are adding water in presence of Hg2 plus and H2SO4. Okay, you have to add H plus OH minus. So now what will happen? Here this bond will shift to here, not only to here or here, both are same, symmetric. So that will be become CH, double bond CH, this become minus, this become plus. So this H plus, you can see guys, this H plus will go and attach with negative, this OH minus will go and attach with positive. So that means the compound will be CH along with the CH which will go and attach, this OH will go and attach along with the CH, CH2, I mean this will be, which is coming, this H is coming, this will be become double bond. Now you got a compound CH2 double bond CHOH. This is the enol. This is a enol. Enol, because double bond is there, alcohol group is there. So that's a enol. That enol is unstable, that will undergo rearrangement. Hydrogen shift will be there. That is called tautomerism. Tautomerism. So because of tautomerism, this hydrogen will go to here and double bond will come to here. So that will be become CH3, CHO. Ethanol you will get. Ethanol. If you are taking ethyne, you will get aldehyde. Any other alkyne you are taking means you will get what? Ketone there. Ketone. Okay, so that keto enol tautomerism you learned already. So while we are looking our options, we can say that A and B. A is what? C2H2. A is C2H2. Here two options are there, C2H2, and B is CH3CHO. A. So option A is the correct one. If we are oxidizing this one means it will be become what? CH3COH, but there is no oxidizing agent. If H2O2 or something if you are using there means, or CaMNO4 or something if you are using there means, that will be go to what? Acid. Okay, ready? Yes, Ashmita? Yes, that's the power. Okay, yes. So then we can move to the next question, 18th question. Listen to me. Identify Z in the sequence. Z in the sequence. While we are looking the question, I try to relate all the chapters. Okay, here we discuss aldehyde also. I try to relate like that. So don't forget the ideas. Okay. So organic chemistry is like that. They can ask twisting question also. They can ask, but this is not that much tough, somewhat. Okay, but you can adjust. I hope you guys. This kind of question only we seen in the JEE session first session. Okay, so that kind of question only is going to come in the JEE session 2 also. Some twist will be there. Okay, anyhow we have to expect for both. If you are there along with us means obviously we will do it. We will make it. Okay, ready? Okay, guys. So here while we are looking this one, CH3, CH2, double bond CH2. And in presence of HBr and H2O2, anti-Markovnikov of addition. What is Markovnikov of addition? Rich become richer. What is Markovnikov of addition? Rich become richer. That means H plus and Br you are adding means normally this H plus will go to, you have to remember, rich become richer. Okay, that idea I already taught you. Rich become richer. Okay, so normal Markovnikov means here along with carbon 2 hydrogen atoms are there, along with this one, I'm sorry, here one hydrogen is there. So here one hydrogen, here 2 hydrogen. So this H plus will go with a more number of hydrogen containing carbon. Normally Markovnikov. Anti-Markovnikov, because of the presence of peroxide, it will undergo Karash effect. What effect? Karash effect. So Karash effect takes place means what will happen? Karash effect takes place means this Br minus will go to here and H will go to here. You will get CH3, CH2, Br you will get. CH2Br you will get. Now this is a halo alkane. This one you are treating with a, what is this? C2H5ONA. So this is a sodium alkoxide we are treating, that is Williamson synthesis. What will happen? This Na and Br will go together and what you are going to get? CH3, CH2, O. Then here CH2, CH3 will be coming. So what's the answer, guys? Tell me the answer, please. So here I'm sorry, here 4 carbon atoms are there. Here 4 carbon atoms are there, not propene. It is butene only, I'm sorry, chemistry god. So here 4 carbon atoms are there. So here CH2, here this CH3. So that means CH2, CH3. So 1, 2, 3. So this is ethoxybutane will be the answer. So I hope option ethoxybutane. Option C will be the correct one. Here 3 and here 1, 4 and here 2. Option C. Is it okay, guys? Is it okay, guys? Yeah. William by either synthesis. Yes. Williamson's either synthesis. Yes. Great. And core games. Yes. Siddharth. Yes. That's it. Keep the spirit. Okay. And so many are watching from Kerala also. So many are watching from India. So while we are seeing that, while they are attending our class, means we are feeling that much happiness. Okay. So you have to understand the questions and the concept. Okay. That's it. We will make it. Okay, guys. So we have to go to the next question. 19th question. Which of the following acid react to reverse to Markovnikov rule? That idea you have to remember. Only HBr only can give what? Anti-Markovnikov rule. Anti-Markovnikov rule. HCl cannot give. HCl cannot give because in presence of peroxide, this HCl bond cannot break homolytically. But HI bond will break homolytically. But the problem is that H free radical, I free radical will form. Rather than reacting with your alkene, likewise one more I free radical that will form a bond, that will form I2 rather than reacting with the alkene. So not the expected product. So only anti-Markovnikov addition means the reaction mechanism, you know, free radical. So that free radical formed is possible only in the case of HBr. So answer is HBr. Okay, ready, guys? You got the idea now? Okay. Then we can move to the next question. This is the next question. On treatment with chlorine in presence of sunlight, toluene gives the product. It's a symbol. Already +2 already you learned that idea in haloarenes also. Toluene. This is toluene in presence of toluene. Okay. This is toluene. Toluene you are treating with the chlorine in presence of sunlight. Sunlight, while you are treating, what will happen? In presence of sunlight, in presence of high temperature, in presence of very hot, okay, high temperature and all, free radical substitution will take place. So instead of this hydrogen, this benzylic hydrogen, okay, here along with the carbon, 3 hydrogen atoms are there. Instead of this one hydrogen, what will happen? Chlorine will go and substitute. So you will get what answer? Benzyl chloride. Then again that hydrogen also will be substituted benzyl chloride, like that it will go. Anyhow we can check the options. Not orthochlorotoluene. In the benzene ring nothing will happen because benzyl free radical is more stable. So benzyl chloride is the answer. That's it guys. Okay, now I think today math session is not there. Only chemistry session is there. Okay, so I hope you have to study. We are going to finish the topic today. Okay, so again you have to watch the video one more time. Okay, and if you have any doubts, any queries, then means you have to put that one in the comment box, guys. So we will be there again I am telling, we will be there up to your examination. So please try to watch the videos, please try to study and work hard. We will make it, guys. Okay, bye, good night.